Hello, welcome back. I hope you had a good coffee break and are properly caffeinated for our next speaker. His name is Matej Gera, and he will be talking about a very interesting subject of infrastructure monitoring, comparing Prometheus and an OpenTelemetry.
So, thank you. Hello, everyone. As it was said, my name is Matej Gera. I'm originally from Slovakia, but I live and work in Berlin. So this is one of those rare occasions when most people get my name right at the conference. So thank you for the invitation, and it's a pleasure to be here at my first KCD, almost at home in Prague. And today I'll be speaking about monitoring Kubernetes infrastructure with Prometheus and telemetry. We're going to take a look at their comparison, where they kind of intersect, and I guess we can try to answer the question, is this kind of a battle, is this a competition, or rather cooperation? So we'll be looking at the current state of both projects. We'll shortly look at where, what are their philosophies, where are they coming from, and how their state looks in current year, 2024. We will look at the overview of monitoring for both Prometheus and OpenTelemetry. We'll kind of look at how their model looks and how their inner functionings work when it comes to monitoring Kubernetes clusters. We'll take a look at some pitfalls. What are some things that you might need to look out for if you're using one or the other, or if you would like to migrate, and so on. And we'll try to wrap up with some conclusions from our learnings today. So maybe quick show of hands, who is already using Prometheus to monitor your Kubernetes clusters? Okay, so that looks like 30% maybe. Is anyone using OpenTelemetry? Okay, that's even 5% maybe. So how are you monitoring your clusters? What are other people using? Let's see. But anyway, why are we here today? Let's start from observability as a term. Why we need observability? We need to understand the state of our clusters, of our infrastructure, of our applications. We want to know what's going on inside of them, but we don't have magical glasses that we could see inside of our machines and read what's going on. So we need to somehow hook up our applications, our infrastructure, and see and export certain signals that will tell us what's going on inside. Now, when we're talking about monitoring, we'll be talking purely about metrics. So we will be talking about certain quantifiable values that we get out of the things that we monitor, right? And as we know, in the CNCF landscape, there are currently two projects that deal with monitoring. One of them is OpenTelemetry, which is like the new kid on the block, which is kind of the emerging cloud-native, kind of vendor-neutral way to do your observability. It's kind of it's a little bit more elusive to define it because it cuts through many different aspects of observability. Some of you who heard about OpenTelemetry might equate it to the OpenTelemetry collector, but it also includes its own protocol for transferring data, OTLP. There is a whole set of SDKs for different languages, APIs. There is a big specification that states how things should be implemented. So it's a big project that is really multifaceted, and it goes beyond beyond metrics as well, because it deals with all the major signals, traces, logs, metrics, and profiling is coming very soon. But it also has much richer or much more complex data model compared to Prometheus. Then on the other end, Prometheus, it's kind of more like a staple, trusted utility in the world of monitoring that we know. It has this also quite well-known exposition format that it uses. Also, a big part of Prometheus is the storage. It's time series database, whereas OpenTelemetry omits this part by design, where this is intended for your vendor to provide the storage. So there are some overlaps, but there are also some things that differ between both projects. And where are the projects in current year 2024? The way I see it, there is more and more interaction between the projects. There are people from both camps that are interacting with each other. So we have people coming from OpenTelemetry to Prometheus, but we have also many important people and core maintainers of Prometheus dealing with OpenTelemetry. And I think the biggest sign for that there is an interest in cooperation is coming from the Prometheus project and its members, who just recently declared their intent to commit themselves to OpenTelemetry, and seeing the adoption rates and the interest of users in OpenTelemetry to cooperate with the OpenTelemetry project and, for example, provide the missing parts that are not in OpenTelemetry. So, as we'll talk about it on the next slide. So, currently, OpenTelemetry, it's a little bit different story when it comes to its relationship with Prometheus, because from beginning, OpenTelemetry intended to support Prometheus as one of the major protocols out there. It was also defined in specification as such. It also has the notion of Prometheus receiver, which I will talk about a bit later, which basically enables you to use it as a drop-in replacement for a Prometheus instance. And there's also cooperation going on in the space of operators. And OpenTelemetry is also putting a lot of work into kind of a non-technical work, or work that's just outside of writing code and specs. So there is a working group for Prometheus. They are doing panels and surveys, and they really are trying to nail down the interests of users and their pain points and their and where they see need for help. On the other hand, as I said, Prometheus, there was this statement from the project about intention to support OpenTelemetry. For example, they want to be the default storage solution for OpenTelemetry, whereas, as I mentioned previously, OpenTelemetry by design initially did not include storage as part of the project. And there's also further work going on in trying to bring both closer together, since there are differences in data models and other issues stemming from the differences. So I think this is looking less as a battle and starting to look more like where we can cooperate, how we can fit in together, how OpenTelemetry, how Prometheus can fill maybe the missing gaps in OpenTelemetry, and how it can also support OpenTelemetry. If you want to learn more already today about each of those projects separately, you have opportunity to look at these talks from my fellow speakers that are on the program a bit later. So now let's look at the actual infrastructure monitoring and how it looks like and how it compares between Prometheus and OpenTelemetry. I'm going to start from looking at what we actually want to monitor. In the simplest term, we will start by looking at our nodes where we run our workloads, because we want to know how is our node doing. So even the underlying structure, whatever it is, if it's running on a virtual machine, you want to know how is it, what's up with it, how much resources are being used. And you can keep adding on these categories, like you would want to know about processes, about networking, maybe about kernel. So we could probably add even more categories of metrics that you're interested in here. On the other hand, we also want to understand our workloads. So what is it that actually is running on my node that is already being managed by Kubernetes and it's part of my workloads. And we should also not forget that we also need to monitor the Kubernetes components itself. So here I put it under the host. I put there Kubelet and kubeproxy. So we also need to make sure that these components are healthy and running without issues as well. So we have one node now, multiplied it by all the nodes that you have in your cluster, or even multiple clusters. On top of that, we have the control plane. So this is another part that we might need to focus on. Maybe depending on if you have a managed solution, you might find this maybe less important or interesting, but nevertheless, it should be part of your strategy or part of your thinking when you think about monitoring your cluster. And we want to also know about the overall state of our cluster, right? So it's not just these independent nodes or independent components, but we want to understand overall what's going on. So this will relate to different resources that you might have in Kubernetes, like you might want to know how many deployments you have and so on. And again, for the components, maybe if you on the control plane, you might want to know about how many requests there are to your Kubernetes API. There are any errors? What is the traffic? And again, like you want to know overall working of your components. So it seems like a lot. Now we want to have all of this information, but how do we get it out? As I was mentioning, since Prometheus is kind of the staple, the daily bread and butter, as it used to be in the monitoring world, in the CNCF, this is also the way which Kubernetes decided to provide the metrics. So at each component, you will have a special endpoint /metrics where you will see metrics for that particular component. And this is a well-known format that is understood by Prometheus, and it's able to read this data and receive it. We'll look at it a little bit later, but if you're not familiar with Prometheus, this is how the metrics would look like if you opened up this /metrics endpoint, and we'll look at it a little bit later. So as I was saying, in the components, we have the /metrics endpoint. There is one a little bit more special use case for the Kubelet itself. It doesn't have only the /metrics endpoint, but on top of that, it provides certain extended metrics about more things that are related to your kubelet, or actually to your worker node. So, for example, the metrics /cAdvisor is quite useful because it gives you it gives you more information or more metrics about your containers, such as CPU, memory usage, disk usage of the containers. And this one is kind of baked into the kubelet, so you can leverage this as well for your monitoring. So this gives us a good starting point. As we said, we can use Prometheus who understands already this exposition format, and you can run Prometheus. You can deploy it on your cluster, or you can run it in as a stateful set, or maybe in a different configuration. That is now not important, but basically it takes care of you. It takes care of scraping this data in certain intervals, and then it either can store it by itself if you use Prometheus in the server mode, or as an agent, it can forward the data further to a different. You could use, again, you can use a vendor for your storage, or you might use a different project or a different storage solution that you run yourself. But this doesn't seem like a complete picture, right? We said that we need to monitor the individual components. We want to also look at what's running in our workloads, and we have this partially covered, but we're still missing the metrics about our nodes, so the stuff that's below, let's say, below Kubernetes. And we also don't have overview of the cluster itself, right? So how do we do that? Because these components do not expose any kind of /metrics endpoint. There are no standalone. There are not a standalone application, right? Your host. You need to figure out a way how to expose that information from your node, right? So for this, you need to run a separate specialized binaries that are called exporters within the Prometheus community. And they do exactly what I just said. So they understand the internal workings of whatever they are supposed to monitor, and then translate that information, those metrics, into format that's understood by Prometheus. So this then can be scraped just the same way as any ordinary /metrics endpoint would be scraped. And in our case, we are mostly interested in the node exporter. So this is one of the most used exporters that gives you metrics about your node. And you also have the kube state metrics, which is kind of an add-on agent, a separate project that communicates with the Kubernetes API, and it exposes the metrics about the state of your clusters. And kube state metrics gives you already quite a lot of advanced and detailed metrics, so it's quite powerful if you think about all the different objects you can have in your Kubernetes and what type of metrics you can expose about them. So it can also get very expensive. And with the node exporter, we will get information about our actual host, about CPU, memory, and so on, all of the groups of metrics that we set previously. Now let's compare this with how we would do this in the OpenTelemetry way. Kind of similarly to how Prometheus can be understood as an agent that sits somewhere on your cluster or somewhere near your infrastructure, and it's periodically looking at these sources and pulling the data from the sources. Similarly, there is a tool or binary or a project within the OpenTelemetry that is called Collector, and Collector's purpose is exactly the same. So it sits somewhere near your infrastructure and it's simply collecting the data. The difference, of course, Collector is has a much bigger surface because it also deals with other types of signals, so not just metrics, and it has some different capabilities than the Prometheus itself. So it has some more processing powers, and it understands multiple different protocols and formats. So you could also hook it up with, for example, statsd or any other major protocol that is supported. So not only that, but Collector has a notion of receivers. And what are receivers? You could think of them as what I said previously in Prometheus exporters. So they are components within the Collector that are responsible for collecting data about certain particular component that we want to monitor. So if we compare it with Prometheus, these are not external binaries or external programs that you need to run separately, but they are part of the Collector itself. So it's all part of one configuration, one binary, and so you can just run it all in one container, basically, in the Collector. This will kind of be parallel to what we've seen previously. So you will have the host metrics receiver that will be collecting metrics about your host. We will have the Kubelet stats receiver, which deals primarily with the Kubelet metrics and pulls them from the Kubelet API. And we have the Kubernetes cluster receiver that then deals with the whole cluster. So it would look something like this if we try to visualize it. So where we arrived, we've seen both Prometheus and OpenTelemetry, and we see how they can collect all of these groups of metrics. So we will know about our workloads on the nodes, we will know about our hosts, we will have understanding of overall what's going on in our cluster, about its state, and we will also monitor individual components within Kubernetes. Now, if we try to compare both a little bit, there are differences in the data model between Prometheus and OpenTelemetry. The major one that I'll show an example just in a moment is or one of the major ones is between the naming conventions and the supported characters, whereas Prometheus is quite limited character set, and it depends mainly on using underscore as a separator, whereas in OpenTelemetry you use this dot hierarchy, so the names will contain dots instead of underscores. And there are some more kind of advanced or more detailed differences in the data model, such as the OpenTelemetry has a notion of resources, which are metadata about the resource that originated that telemetry signal, whereas in Prometheus you would probably use this as a label, or you can sometimes have a special metric called target info. And also OpenTelemetry metrics is kind of a more complex type system, so it's not just counter gauge, histogram, and so on, but it's a bit more nuanced, and you can take a look at it if you're interested. So we look at a very practical example. We will want to again get information about our node. So we want to monitor our host, and we want to know how much CPU work it is doing, a very simple task. So if we look at the Prometheus, again, maybe if you went to the node exporter and you look at the /metrics endpoint, you would see, you would take a look at this metric maybe in your browser, so it's even human readable. You can see we have there some some directives, the help and type directive that describes the metric and its type. And then we simply have the node CPU. It tells us it's in seconds, and the total suffix, it's also a kind of common way to denote this in Prometheus. And then we have the labels, which tells us which CPU this is, like physically or logically, and what kind of mode was the CPU doing the work. Now, if you look at the OpenTelemetry, since this OpenTelemetry doesn't have like a nice text exposition format, it's kind of harder to compare. You can run a debug exporter in collector that would kind of print out your metrics. But I think I just took this from the documentation, and I think we can already compare it and see differences. So this should tell you the same information, but as you see, it's the name of the metric is different. It uses dots instead of underscores in between trying to separate the namespaces. And there you see also the attributes below. So this will be included similarly to what we see above, right? So you have the CPU number and you have the mode of the CPU. So in that sense, they're similar, but not quite the same. Now, one thing that I didn't mention yet is about possibility to also use the Prometheus receiver in your collector. I was mentioning in beginning that you can use this as a drop-in replacement for a Prometheus. So practically also have power to use Prometheus agent or Prometheus way of collecting metrics that's baked into the collector. And again, it should work one-to-one with your Prometheus instance, since it's intended to be a drop-in replacement. So again, imagine that you wanted to get some extra information from an exporter, or you would want to get metrics from the components themselves. You are also able to do it this way, right? So you can kind of what I named here, do a mix and match approach, so you could get some metrics about your cluster from the receivers. You could get other metrics from the exporters or the components themselves through the Prometheus exposition format. Now, when we look at some of the things that you should be thinking about when monitoring your cluster and choosing between these two, one important thing is with regards to kind of the extended things that come after you collect those metrics, right? You want to visualize them, you want to alert on them. And I think here is a big difference between how currently there's support in community. So in Prometheus, there are well-established projects and tools that help you to have a pretty good experience outside of running right outside of right out of the box. So again, you can use Prometheus as a storage. You have the alert manager. You have the mixin for your Kubernetes that will create the dashboard for you. And so this, if you do this by yourself, it's quite easy to do it for Prometheus, whereas for OpenTelemetry, right now you have to rely quite heavily on your vendor. So depending on their storage solutions, depending on their product, depending on what they provide to you, you are kind of relying on using them. And also, migrating might not be the easiest if you would consider migrating from Prometheus to OpenTelemetry, because as we've shown, if you want to use those OpenTelemetry metrics, there are differences in naming, there could be potentially differences in type of metrics. So we're monitoring the same thing, we get kind of similar metrics, but the naming will be different, and it's not guaranteed that even the values denoted are the same. So if you try to use a if you try to use Grafana dashboard for existing Grafana dashboard or the mixin for your OpenTelemetry setup, it would not work, right? It would also be like a breaking change for you. And yeah, the important thing also with the storage. So as I was mentioning previously, Prometheus intends to become a storage for OpenTelemetry metrics as well. It has experimental support, but currently you would probably, again, you might want to use OpenTelemetry if you have a vendor who supports it and who will accept the data in that format. Also, when looking at deployment modes and scalability, there are quite good ways to deploy the Prometheus project. There we have the operator, we have a quite developed chart, the Kubernetes stack, that focuses specifically on monitoring your Kubernetes cluster. And we have something similar that's coming up in the OpenTelemetry world, but it's still under development. It's not quite there yet. As I was also saying, there's difference between using these external components with Prometheus, so we have to run these extra exporters, so that's kind of extra overhead, extra binaries, extra pods, containers, whereas these are kind of internalized in the OpenTelemetry world. And you could argue there might be some kind of duplication of work going on because you're doing the same thing in OpenTelemetry as internalized, but in Prometheus as externalized. But in the end, you want to get the same or similar data. So that's another thing to consider. And also, one more thing is depending on when it comes to your experience, right? So with Prometheus, this is just one agent that's collecting metrics, but you might want to use collector if you also want to collect traces, metrics, and logs, and you want to have kind of a seamless integration or seamless experience, maybe for your whole team or company. Another important thing, this is why I was mentioning the possibility to scrape component metrics or exporter metrics with collector, because there are still some missing pieces in those native receivers, so you won't get the same, the surface of the metrics won't be the same between OpenTelemetry as we shown the setup and Prometheus as we shown the setup. But again, you can kind of, if you want to, you could mix and match this approach. So you could, for example, scrape the kube state metrics with your OpenTelemetry collector to get these extra cluster metrics that are missing. I think it's also important to mention in general, like the stability of the projects, and obviously Prometheus is a much longer project, has been in existence much longer. It's kind of much more stable. Also, the project maintenance is really well developed, although OpenTelemetry is doing a lot of work there as well. It has long-term support versions if you're interested in that. Especially the OpenTelemetry not having, like with the collector, it's still not being, at least with those extra components that we talk about, like the Prometheus receiver still and the Kubernetes related receiver still not being, in a stable version. There's potential for breaking changes happening between versions, which is not always nice. Also, I think it's also worth mentioning how do they compare with when it comes to resources, and this is something that also you might want to consider. Prometheus obviously might be more performant when it comes to collecting metrics. I've seen some talks and there are some information in the community about these comparisons, but I think there is more information necessary to do this, to properly compare both, and also take into consideration, obviously, that OpenTelemetry has a more complicated pipeline in the collector, and also the fact that you collect different types of signals besides metrics. So I think this is how we can wrap up most of these things I was mentioning as we were going. So I think OpenTelemetry might make sense if you're building something new, if you want to have a support, if you have a support from your vendor to do this, if you might want to unify the experience between different signals, or you might want to have the more powerful features that are provided by the collector. On the other hand, with Prometheus, this is something more stable. This gives you a really nice experience when you do it by yourself, including storage solution. And also if you have, as I was showing, maybe some need for more detailed or advanced metrics that you maybe cannot get from OpenTelemetry that easily. And again, it's a battle-tested horse, good performance, stability, support. So I think this gives you a good understanding of both. And with that, I conclude my presentation. Thank you. I don't know if there are any. Okay. Okay, in my company, if I didn't mention it, maybe I forgot in the beginning, I work for an observability vendor, so if you have a need, check us out. My team, we primarily work I work in a team that deals primarily with the agent side of things, so I help figure out configurations for our customers to how to use the collector, the OpenTelemetry collector, since that's our project of choice. And so I'm primarily using OpenTelemetry. That's what we're kind of what we're suggesting our users to use as well. That's kind of what we support. So that's mostly it from my side. It's OpenTelemetry. Previously, I was also involved in Prometheus and Thanos project. That's kind of extension of Prometheus. But I'm now mostly involved in OpenTelemetry. I don't use it myself for monitoring, but I help others to use it. And what is the future of telemetry collection? I think this can be a heated debate, but as OpenTelemetry is showing, you can do both approaches, or you can do the approach that you think has more advantages or disadvantages. So I think the answer would be both, or whatever you want.
Thank you very much. This concludes the presentation. 5 minutes break and we continue.
Thank you.